Hi, I'm Paul. Welcome back to another Blazor brief. Following on from the earlier brief regarding BEM, the CSS naming convention, today we look at how simple it is to create your own CSS framework that you can use with Blazor. Although this brief is regarding Blazor, the creation of a CSS framework is applicable to any web project. It is possible to create a CSS framework without a CSS processor. However, that would be extremely tedious and not the approach taken in this video. To get you started, as it's been a couple of years since I created my last framework, I thought I would start a new one from scratch, which is the project we are looking at now. The project is available on GitHub to download, and the link is in the video description below. My plan is to keep this as a separate project and to keep adding to it for my own use, adding more menu items for pages to show all of the other items within the framework which will act as documentation. Quite simply, and although you have not seen the project structure yet, for any new project you can just drag and drop a single folder called core, which holds generic Sassy CSS files from this project to a new project as a starting point. There is nothing stopping you from just using the generated CSS file, but I would just copy the files to each new project, so in effect each project has its own isolated framework. Okay, so what are we looking at? Currently on screen are the available colour palettes, and if you've used frameworks such as Bootstrap, then the colours named Danger, Warning, Success and Info will probably be familiar to you. These are just state context colours. For example, you might use Danger for error messages or Info for alerts. You can configure all of the colours. These are not fixed. You change a Sass variable and hundreds of CSS variables, text, opacity and background colour classes get generated for you. This project allows us to create the framework and view the results of it. The main and most important colours are the primary, accent and neutral colours, and to be honest, if you're like me and have zero design skills, then you will probably only ever need to change the primary and accents colour Sass variable values and be done. You can of course change whatever you like and add more colour palettes. There are functions within the sample framework that take a colour value and generate all of the CSS classes and CSS variables for you. As this is Blazor, I made a dumb colour swatch component so I did not have to copy and paste the markup for each colour. So if you add a new colour to the framework, just add another swatch component to the page to view the results. When I say add another colour, I mean add another named colour such as secondary, as it's the names that are important for the framework, not the actual value of the colour. For each colour, the framework will generate using configurable Sass variables lighter and darker colours by mixing white for lighter shades and black for darker shades. I set the default for this to use 10% increments. Having spent a few hours playing, the neutral opacities make it easy to create relatively nice looking dark modes that we will discuss in a moment, but again, I'm not a designer. What I consider okay would probably have designers up in arms. The framework will also generate what I call canvas light and canvas dark variables for each colour. So for the primary colour, it will generate a variable called canvas primary light and canvas primary dark. These are for the base background colours for both light and dark modes. By default, the Sass variables are set to generate a light canvas of each named colour by mixing that colour with 95% white and 80% black for the dark canvas. The text colour is also mixed with percentages of black and white for the light and dark modes. Before I continue, it should be noted that this project has no JavaScript and there is no Blazor code that adds or removes CSS classes and styles in response to events. I say this as some of you may have noticed the accessible switch that we built in an earlier video at the top of the screen displaying light mode. I copy and pasted this switch component into this project. Those of you that watched that video may remember that the switch toggles the ARIA checked attribute, something that CSS can respond to. In CSS you can add selectors for attributes, so in this project I just added a selector that changes a few CSS variables when the area checked state is true. Let's see the results. The browser dev tools sometimes show you the accessibility contrast ratios when selecting elements. Not sure why it doesn't always show them, but for some things it definitely does not show them. For one item that it does not show the contrast ratio for are the focus outlines. So in the framework I added a Sass function based on the Web Content Accessibility Guidelines math for contrast ratios to be able to calculate these. If you look below the warning colour swatch, you will see contrast ratio information regarding the accent colour when used for focus outlines on the primary colour or primary canvas colour. The values on screen are the ones generated by the Sass function, and as such I had to use a class using the after pseudo element class to display them. I created this before I built the colour swatch component and before I added the contrast ratio math in C#, so you could amend this swatch to use the C# values if need be. The Sass contrast ratio function is still used to determine which text colour to use for button background colour modifying classes, either black or white text depending on which has the higher contrast ratio. Whilst on this page, one thing you should note is that the only CSS that we are using is from our own framework, which includes a couple of grid classes. This page uses a grid with auto columns, so no breakpoints are required. Let's minimize the page to see the results. Under the hood it uses CSS grid with auto fit, so for this page I just use one of our framework classes that specifies a column width of 700 pixels and the CSS grid just does the rest. The site is flat looking, but if you prefer to add depth, no problem. There are 5 elevation classes that add box shadows in the framework for this purpose. Let's add one of these classes to both the side navigation and header areas to see what it looks like. Now let's look at the typography page. As I am not a designer, I just opted to use a typographic scale called the major third, which uses a scale factor of 1.25. In the framework there is a Sass function that takes a scale factor and generates all of the CSS variables and font size classes. I also added one additional font size which I call FS label, which has a size of 0.875 rem, which I have found to be a nice size for control labels, hence the name. I have also set its weight to 600 instead of the regular 400 weight. This screen also shows the 9 font weights, and as I like simple, for this project I just added a single variable font file, Roberto Flex, that contains all of the font weights and styles, so there is no need for additional files. Now let's view the sandbox page. As the name suggests, this page is just for trying out ideas and to ensure the created styles work as expected. These box-like structures are in a typical configurable 12-column grid system that uses breakpoints. I set the top 2 boxes to use an extra large column class that spans 6 columns when at the extra large breakpoint size, and then span 12 columns at smaller breakpoint sizes. All of this is configurable just by changing a couple of Sass variables. Before I minimize the page, I should mention that the layout for this page and for all the pages is defined in a partial file called app layout. I did not put this in the core framework folder that you will see in a minute, as I created it specifically for this site. However, there is nothing wrong in having a layouts file in the core framework for reusable layouts. When the page gets smaller, predictably the boxes change to take all of the available width, with the underlying CSS grid creating new rows when needed. As the page gets smaller still, the navigation menu collapses, leaving only the icons. Nothing new. We go smaller still and the icons go off screen with the iconic burger menu icon appearing. We click on that burger icon and it changes slightly to a different icon. Nothing special, but none of this required JavaScript, nor did I have Blazor add any additional CSS classes for changing the burger icon when it was clicked. I am sure you know the trick with the burger menu. Just style a checkbox and use its checked attribute in a CSS selector. The icon switching is done by using Sass placeholders and the extend directive to create different selectors with the different icons that the breakpoints then activate. You can do this manually, but the placeholder and extend directive saves copy and pasting. I have already mentioned that the change from light mode to dark mode is achieved simply by changing a few CSS variables, which we will look at and discuss shortly. But there is one issue with this that we should discuss now, so I can give you at least one way to negate the issue. There are other ways, but this is simple and the approach that I take. Look at the switch in the header area. This remains the same colour irrespective of whether the site is using the light or dark mode. As this colour is quite dark, for contrast we need the switch to use its colours designed for when it's displayed in dark mode whilst on the header. But did you also notice the other switch component at the end of the row of buttons, which is currently on a light background but should change when the mode changes? The text colour used by the switch is just inheriting its parent element's colour, which changes, as I did not assign the switch a common control text CSS variable that I would have used if it were not for trying to keep the switch as close as possible to my prior video. However, I can still highlight the issue. I wanted to use the accent colour for the focus outlines, but the accent colour on the light background fails the WCAG contrast ratio requirements, but passes when on a darker background. In order for it to pass the contrast ratio requirements when on a light background, I needed to change the focus outline to be a couple of shades darker. However, that change does not affect the switch component on the header, which is using the default accent colour. Equally, when the page changes from light to dark, the switch next to the buttons will change to use the default accent colour. We have two instances of the same component on the page, but one is reacting to changes whilst the other one remains fixed. If you think about this, you will realise that you need some sort of mechanism that allows you to stipulate which components should change with light or dark mode changes and which should remain fixed, using the best mode that suits their page location. I have already mentioned that the light and dark mode is simply achieved by switching CSS variable values. But how do we have these changes only applied to certain components? It's a tricky problem to solve, and it could require a whole theming framework to be built. However, for my own use, I use a very simple technique that may meet your requirements as well. All I do is have all of my components implement a single parameter, which is an enum consisting of 3 values, the default value being dynamic. The other 2 values are on light and on dark. If the parameter value is not dynamic, then I just have the component add a data attribute called static with the value of either dark or light. I then add 2 attribute selectors, one for dark and one for light, adding and changing the appropriate CSS variables in those selectors. CSS variables are scoped, so if we change a variable at the body level, it filters down. But if we change that same variable lower down, the previous upper levels are not affected. Only the current element and its children will see that change. By using a simple data attribute, any component that has advised that it has been positioned on a fixed dark or fixed light section will get the appropriate values, irrespective of whether the site is using the dark or light mode. The components without the attribute will change as the CSS variables change. It's that simple, and thus far I have had no issues using this scheme. You may be wondering, what if I have themes? Does this mean that I need lots of attributes and attribute values? The answer to that is no. The issue just described was only regarding contrast ratios on dark or light modes. For themes, when using CSS variables, it's as simple as adding and removing a class or updating a single attribute value with selectors that then assign the appropriate CSS variable values. The dark and light mode variables have already been taken care of. For example, suppose you had 3 themes called red, blue and green. You would add 3 attribute selectors that apply the appropriate values to the known CSS variables. To change themes, you just set an attribute on the most appropriate element, such as the body tag, with the value of either red, green or blue. If you have used the common name CSS variables, then the dark and light modes just work as normal, as they will be using the new primary colours from the theme. Basically, when you build a component, try to use common CSS variables where applicable, and everything will change together if using any sort of theme, dark or light mode. In the sample framework, I have suggested a set of variables that could be used for various parts of any component, so that when the value changes, all components that use the variable will be affected. In my past videos, I have intimated or have used CSS variables exactly for this purpose. Look at the switcher's track and focus colour. Let's quickly change the primary and accent colours, like switching themes, before discussing the Sass variables. I am manually doing this by changing the underlying Sass variables and recompiling the CSS on save. In production, we would just simply change the CSS variable values in a predefined selector based on the user's choice. The track colour now uses the primary colour, and the focus outline has the new light green accent colour. Using CSS variables makes doing things like this really easy. Earlier I also mentioned that opacity values make it easy for creating dark modes. Let's change the canvas colour from the canvas primary dark to the canvas neutral dark. The canvas primary dark is our primary colour mixed with black. The canvas neutral dark is the neutral grey colour that can be used with any colour, also mixed with black. Whilst in the general partial file, you may notice the use of the data attribute just discussed that is used to keep the switch using the normal accent colour for its focus ring when on the fixed darker heading area colour. Now using the canvas neutral dark background, it's the neutral grey opacities over a dark grey background, so there is no primary colour coming through. You can adjust how dark or how light or how much colour you want with the opacities and with the colour percentage mixes to get the look you want. This is perfect for my needs, but you can change the scheme to whatever values you like, as you are in full control of the framework. Let's go through parts of the project used for the CSS framework. Despite removing all of Blazor's default pages and styles, I have left its folders structure intact, just adding additional folders and pages to try and keep it familiar for you. However, personally, I use my own folder structures and generally remove all of Blazor's. If you have watched any of my other videos, some of the folder and file names should also be familiar to you. For this project, I just used the Blazor Server Interactive Global template, as it's all we need and the hot reload works fine, enabling us to see the changes on save as we add styles. The only thing to note when using hot reload for CSS is that you should periodically clear the browser cache to prevent erroneous displays. In Blazor's default components folder, I just added a subfolder called Framework for any framework specific components, with folders for each component built for the framework. I amended Blazor's default main layout and nav menu file for our layout structure and page links. In the Pages folder, I added ones to kickstart the framework, deleting all of the Blazor template pages. I copy and pasted the switch we built in an earlier video to show you theming, as well as needing a switch to be able to change from light to dark modes. I've added my usual common folder and subfolders. The only thing to note really is the color utils class, which has 3 simple methods for the math to work out the contrast ratio for accessibility. Currently, this code is not used. I will probably make a contrast ratio checking component in the future and update the color swatch components to use the C# code. As mentioned, I have no idea how the math works or how the figures used were chosen. These were obtained from an accessibility website. The output should be equivalent to the various online contrast checkers and the Sass one used in the framework. I have added my usual assets folder and CSS subfolder to the web root, but with a fonts folder inside the CSS folder, as I have included a variable font as a local resource. Again, as usual, I have added a corresponding assets folder to the project with an SCSS subfolder for all of the Sassy CSS files. I used my normal Visual Studio extension for the Sass preprocessor and used the same values in the configuration file that I normally do. A link regarding my setup of the preprocessor is in the video description below. Looking inside this folder, you can see that I have also added a subfolder called Core. This folder would contain all of the Sassy CSS framework files and is the folder that you could just drag and drop to any new project, so each project has their own unique framework files as opposed to just copying the main CSS file that is output by the Sass compiler. You would also need to provide a fonts folder and a font file in the new project if using the framework font. Please note that Sass namespaces starting with numbers are invalid. By default, excluding the underscore, the name of the partial file will be used as the namespace unless one is specified. To negate this limitation, I have used as star to both remove the namespace requirement and stop the error that would occur if you try to use a namespace starting with a number. You can and should specify a namespace on larger projects, which is then used as a prefix for all variables, functions and mixins to avoid conflicts and to make it clearer where things are coming from when using multiple partials that may contain the same variable names, etc. This framework is small, and given that I put all the Sass variables in one file with the functions and mixins in another, which I sometimes separate, I tend not to worry about namespaces or collisions, but your usage might dictate otherwise. The reason I used numbers was to try and make it explicit in respect to the file ordering and to highlight key project agnostic framework files. The files without numbers, such as buttons and boxes, are files inside the core folder, could be part of the framework along with others such as forms, tables, modals, whatever you see fit. But if these were not generic and usable in any project, then I would not include them in the core. I included these as examples to show you that the core could have much more than just the first 4 numbered files. The files outside of the core folder are specific to each project, with the main Sassy CSS file just consisting of use statements to the files to be included in the output of the main CSS file used by the site. Now that you have an idea of the project structure used, let's take a look at the main 4 partial files so you understand what is happening and as such be able to start your own framework or download this project as a starting point, amending it as you see fit. You should note that Sass does things top down, so order matters. If you have a function in one file that comes after and not before a file that uses it, you get an error. Another reason why I put all my Sass variables in the very first file, followed by functions and mixins and then everything else, always putting use statements at the top of the files. First, the configuration file. This file is basically just a list of variables that are used as inputs for the mixins and functions. Mixins just output CSS statements in the place that they are called from. Functions, on the other hand, return values to the caller. The lines down to number 63 are all about the colours, the hex values, prefixes, names, percentage increments for when colours are mixed with black or white, etc. You can change these values to suit your needs. For my needs, I only change the primary and accent colour hex codes, as I'm happy with the other factors. Next down to line 93 are the values for the spacing and border utility classes, such as grid gaps, margins, padding and border radius classes. Rather than use nested maps, I just use simple variables for most of the values and just a map, think C# dictionary, to map class names to the CSS property names. You can change any of these names to suit. For example, I use M for margin and pad for padding. You may prefer just to use P for padding. I went with pad so as not to confuse with paragraph. If you do change the names, just to remember to do a search and replace in the project, as some of the pages might be using the existing class names. The lines down to 101 are just variables for the default font values. Lines 103 to 112 are mainly for the standard grid type system using column classes and media queries. The device widths are for any media query, with the grid currently being the only user of these in the framework. The app layout file outside of the core files makes use of the device widths for the collapsing navigation section and hiding the burger icon past a certain size. Next, the functions partial file. This is where I've put both the functions and mixins used throughout the framework. As the framework grows, you may want to separate the functions and mixins into their own files. I have placed some basic comments to say what the mixin or function does, and I would suggest just leaving these alone until you are happy creating functions and mixins. I do not wish to deter you from altering them, but working with Sass mixins and functions can be a real pain in the butt at times, given that you do not have any debugger to step through like you do in C#. If something goes wrong, the error message can be completely cryptic and take a while to figure things out. I routinely save, commit, or make copies of working files just in case I cannot figure out what the error message means, so at least I can start again with compilable Sass. I think the best thing I can say about this file is for you just to raise questions if after understanding the Sass syntax something doesn't make sense to you, and I will be happy to explain what and why I did something at the time. File number 3, the root partial file. This is where I put all of the CSS variables that can be used and or redefined, followed by any CSS reset type logic, which generally isn't too much. I think most of the defined variables should be self-explanatory in what they are for, and although they are all important, the ones starting with control are the most noteworthy. As mentioned earlier, for theming components, try to use a common set of variables, so when you change one of these variable values, all the components using that name variable will change. There are probably lots more control type variables that should be added, but that's all I could think of for now. But given it's a living framework, you can just add more when you know what they are. As we are inside the pseudo class root, when we include our mixins, the content is output inside this class. All of the mixins that I have used in the root are for the creation of the color and font variables. I do not bother creating variables for the spacing classes, as for these types I just use rem for the spacing unit. These will just adjust if the browser default font size or HTML element specifies a different font size, the default being 16 pixels equating to 1 rem. After the root section, I then put any resets or defaults for the elements. If you have lots of these, then you may wish to put these into separate partial files. I try to keep the number of files to a minimum where possible. Last, we have the utilities file, which contains all of the common framework classes, 99% of which are generated using our mixins. After the mixins, I have added a couple of classes by hand. To be honest, unless you are already familiar with Sass, it's probably easier just to download the project and play about with things. The only other thing I can add is what I've experienced when using Sass within Visual Studio. You can right-click on the Sass configuration file, compiler-config.json, and enable compile and build. This does what it suggests. I have, however, noticed a quirk with it. If you just select the project and choose build or rebuild, you sometimes get an error. However, when you press the play button, everything works as expected. I have learnt not to worry about this. I think that about does it for this Blazor brief. As always, feel free to leave good or bad comments, and if you do have any questions, I will do my best to answer them. If you do download the project, don't forget to add the Sass extension. A short video for that is also in the video description below, along with the link to the GitHub repository. Until next time, bye for now.